Our assignment in Lesson 100 was to cut all the PIO heavy lifting out of the Lesson 99 code and place it in a MicroPython class. Once that was working, our Lesson 101 assignment was to move the class into a library to hide it all from the user. At most, the user is expected to load the class library, declare one or more servo objects, and set the angle of each servo motor with a call like className.setAngle servo name some angle. Here are the changes to the Lesson 99 code. Our working Lesson 99 code is shown on the left. The code using a class is shown on the right. We start by inserting a class definition on line 2. Our goal is to hide all the PIO related code in the class, so we indent the pin and RP2 imports to include them in the class. The user shouldn't have to know anything about the variables used in the servo calculations, so those variables are included in the class as well. The class will allow us to create up to 8 servo objects. We add a new variable, number of servos, to prevent us from creating more than 8 servos. If we're going to hide any code from an inexperienced user, it should be the assembler code. So we indent that into the class definition too. Without a class, the user would be forced to declare each servo as shown on lines 33 to 43 on the left. We shield the user from all this repetition and arcane detail by replacing all the servo declarations with a single $_init_" method as shown on the right. The $_init_" method will create each servo object and keep track of how many have been created. Notice that the class level variables like number of servos must be preceded by PIO servos period. As in Lesson 99, I wanted to synchronize the start of the servos by setting and clearing IRQ0. The set servo position method sets the interrupt. The unlock servos method clears it. This is an additional call that the user has to make, but the details are still hidden in the class. Moving all of the pulse width calculations and the put and exec logic into the set servo angle method greatly simplifies the while true loop. And deactivating the servos is now also managed by a method in the class. Here we see the result of all these changes. All PIO related logic has been moved into the PIO servos class. One additional change is the addition of the if statement on line 33 and the related else clause. This logic will message the user if they try to create more than 8 servos. Using the class allows a much simpler servo setup, as you see on lines 54 and 55. The while true loop is also much simpler. And here's how it works. Now that we know the class is working, we can move it to a library. Cut the PIO servos class from lines 2 to 52. If you created a class library in a previous lesson, paste that selection into that library file. Otherwise, paste it into a blank Thonny file and save that file to the \lib folder of the Pico W as myclasses.py. With lines 2 to 52 removed, our main program now looks like this. We import the PIO servos class from the myclasses library. We then create 2 servo objects by calling the PIO servos method and passing the appropriate GPIO pin number. And we unlock all the servos and set them to whatever angle we wish by calling the set servo angle method and passing the servo name and the required angle. Much simpler. Even better, it still works. Well, that's it for this assignment. Any and all comments are welcome. Don't forget to like or dislike the video before you go. And feel free to subscribe. Don't forget the notification bell. We'll talk to you next time.